Alright guys, so somehow, some way, I don't know what happened, but my video was cut off and I finished the lesson, but you guys didn't get all of it. So, I think this is where I ended and I'll try to go back and finish explaining a few things. But I think the last thing I was saying at the end of the video was that you can choose anything you want in your table, really, but the point is to try to get close to that value that you are approaching. So for us, it's that 1. So we are starting at 2, but we are decreasing and gradually approaching that 1. So that's what I'm saying here, that you want to try to approach your value. And I'm approaching from the right, from the positive side. So that's why it's a little bit greater than 1. But I didn't write all the notes here because I didn't intend to, because all you have to do here is just substitute your values in. I take each one of those numbers, I substitute that into the function, and the values are there in the table. But what you notice now is that as I approach from the right, the value of that function or the value of that limit is -2. So as I approach 1 from the right, the limit of h of x is -2. So on my next slide, what I did is I kind of summed it up. As I approached from the left, as I approach 1 from the left, the value of that limit is 4. But as I approach 1 from the right, the value of the limit is a -2. So what do you notice there? You notice that the limit from the left and the limit from the right, they're not equivalent to one another. They are not the same. So what that means is that the limit does not exist. Okay, it's that simple. For a limit to exist, the two sides must meet. The values must be the same. It's that simple. So I'm going to erase this really quickly. Where's my eraser? So I can maybe explain. Oops, let's not erase all of that, because some of that I can actually use. So I want to erase this. There's something we already know, because I've already proved this. I've already showed it to you numerically, that the limit does not exist. So what I have here is h of x. I have graphed it. So this is graphically a graphic representation of that function there. So what we want to do is we want to determine the limit graphically without doing all the number stuff, okay? So this is what you call the wall method. Now, I'm not going through all the notes. The rest of the PowerPoint is just giving you another example. It's the same thing all over again. So I'm not doing it again, but I advise you to go through it and work it out just for extra practice. Well, what the wall method says is that you're going to draw a wall. So I'm going to do that in green here. I can draw me a wall at that value that I'm most concerned about. So I want to know, what is the limit as I approach 1? So I want to draw a vertical wall at x equals 1. Okay. So let's highlight this so you guys know what I'm talking about. So what I have highlighted in yellow there, we've already did this numerically. We determined that the limit as you approach 1 from the left is 4. So how do I know that? You look at your graph, okay, and you follow it from the left. Where do you end up? Where do you touch that wall when you're coming from the left? Well, guys, we touch it where at? We touch it at 4. So that is where that 4 comes from. Well, let's highlight this in blue, the second part. Well, I'm saying that the limit as x approached 1 from the right was a -2. So how do I prove that, or how do I find that on the graph? Well, you look at your graph, and from the right, you want to inch closer to that line. Where do you end up? Right there. That's where I touched that wall. I touched the wall at a -2. So now you notice on the left and the right, when I touch the walls, from the left and right, they don't go to the same spot. When you do the wall method, when you approach from the left and you approach from the right, you should be approaching to the same point. I didn't here. I have this big break. I have a gap there. So I have a break in my function or my equation. And so that lets me know that the limit does not exist. Okay, so it's that simple. If I would have approached and met at the same spot, then I would have had a limit, and it would have been the value there where I met. Okay, so that is it. I would advise you guys to look through the PowerPoints, the rest of the notes, but like I said, they are the same type of problems, but it's just a different example. I wanted to do this one because I wanted you guys to see what it looks like when you do not have a limit. So if you have a question, reach out. I don't mind helping. You guys know that. So I hope this helps.